All right, it's time for you to try another exercise on your own. So here I've given you an application problem where Meshgrid will come in handy. I'm telling you right up front, use Meshgrid to solve this problem. Go ahead and pause the video and we'll catch up and I'll review how to do this when you come back. Welcome back. So we're going to open up a new script and I'll include my header cell here to say what am I trying to do. This is Meshgrid exercise. But if it was a challenge problem, you might call it challenge problem 1, challenge problem 2, and you'd also put your name and the date here, or whatever else is asked for in the instructions for your challenge problem. I'm also going to say something about what I'm trying to do. Notice that the first problem here, number 6, just says calculate the interest amount on a $7,000 loan. So we can do that. But then I'm going to go back and change it to be more variable. So if all I had was, what I'm trying to do is calculate the interest on a loan, t equals 4, this is in years. The initial rate for number 6, r equals 0.06 annual interest rate. For number 6, it's fixed, so we're going to go ahead and do that one first to get a sense for how the problem works. And the amount of the principal was $7,000. Principal in dollars. There we go. All right, and so we calculate interest just by doing I equals P times R times T. Oh, don't suppress that output. In fact, I want to suppress these outputs. I don't need to display these definitions to my user, I just need to show them the output. So the interest will be calculated according to this. Do not suppress that output, that's what we want to show them, and then we run section. So we see a few things here. First off, we do have an answer. That's fine. Maybe we should format it in bank format just to make sure that it's dollars and cents, but let's leave that undone. One thing I noticed is that I didn't do clear CLC anywhere. So I have this mess of all these different variables and junk in my command window. I don't need that. So let's clear that out. So we have an answer to number 6. That's done. For number 7, we're going to create arrays for the interest rate and for the principal. The t is going to be fixed at 4 years. But now we want the interest rate to be variable. Instead of just 0.06, we want it to include values from 2% to 7%. Let's see, 0.02, count by 0.01s, all the way up to 0.07. Okay, so now I have an array, a one-dimensional array with all my interest rates in it. And instead of $7,000, what I want is an array from 5,000 to 20,000. I'm going to pause here and let you think about what would happen if I did it like this. From 5,000 to 20,000. I have not specified an increment. So by default, the increment is 1. This would be a lot of columns. I don't need that. I don't want that. Instead, let's give it an increment. Count by 1,000 or 5,000 or 2,000 or something. 1,000 sounds like too much. 5,000 sounds like too little. Oh well, let's pick one. Let's count by 5,000s all the way up to 20,000. And now I would like to do this multiplication. I equals all the p's, all the principals, times all the different rates times the 4, which was the t number of years. But now this won't work. Why? Let's run it and see what error message we get. Incorrect dimensions from matrix multiplication. So the first problem is by using star, we're telling it we want a whole different type of multiplication, matrix multiplication, which we haven't even talked about. But if you've taken linear algebra, you know it's a little bit more complicated than just taking numbers and multiplying them together. So I'm going to change these because now we're working with matrices. I'm going to change these to the dot star instead. Oops, now this won't work. It still won't work, but let's see if we can figure out why. Run section. Now we have the appropriate error for our dot star. Matrix dimensions must agree. Because we're doing element by element multiplication, that's what this means, we have to have the same size. And they're not. We can't do it. So instead, we need to use Meshgrid to make them matrices of the appropriate sizes. We're going to create all new matrices. Let's call it, I'll call it new R matrix and new I P matrix. The I is what we're calculating. And this is what we're going to put into these two outputs as the result of the Meshgrid command. And I need to put two inputs in. Well, the way that we're using it right now. And I need to put them in the same order. Okay? But earlier we just had X and Y and we could do whatever we want. But now I'm saying I need the R's to be R's. They're first. I need the P's to go with the P's. They're second. So I don't need to see the output of this, but I want to just once, and then I'll turn it to suppress. But let's comment this out because I don't know if it'll work yet. I'll erase the pessimistic comment where I said it doesn't work because maybe it does now, and run this section. So here's what we've got, and you can see mine has kind of split off to the side here. But it's columns 1 through 5, and there are 4 rows, 6 columns, 4 rows. The interest rates are here, 2, 3, 4, 5, 6, 7. The principals are here, 5, 10, 15, 20. Okay, if you use different increments, yours is going to be a little different, and that's fine. This paper didn't specify what increments to use. I hope you didn't use anything that created more than like 20 columns though, or 20 rows, because that's a lot. Notice we can double check here. Our new P and new R are both 4 by 6 matrices. Perfect. Now we can multiply them together. The only thing we need to change from this line is that it's no longer P that we need to multiply. It's the new P, and it's the new R. These are the ones that are the right sizes that will work. So suppress the output from Meshgrid. I don't need to see it. I just wanted to check. But for my final version of this problem, I don't need to see it. Run the section. Here's what we get. Mine's split onto 2 rows, but that's okay. Columns 1 through 5, 4, 5, 6, 7, 8. And notice, you might think at first glance, these don't look like big enough numbers. Why is the interest so small? But you might notice up at the top, because of the way we have it formatted, we're getting a little scientific notation here. So this says 1,000 times all of these things. That means this last one is actually 5,600. And somewhere in here is the one we had before with the 7. Oh no, because we skipped $7,000. But all of these are in thousands. So this one represents $600, this one represents $4,000, and so on. Now we have the amount of interest of all these different possibilities, and we can read items off of there if we want to. All right, how'd you do? Meshgrid is not easy to use, but it is well worth it because it allows you to multiply together arrays of different sizes, which can be very handy. So it's good to know how to use it. If you have questions, let me know. I'll see you in the next video.